Mimas Mams, also designated Saturn I, is a moon of Saturn which was discovered in 1789 by William Herschel. It is named after Mimas, a son of Gaia in Greek mythology. With a diameter of 246 miles, it is the smallest astronomical body that is known to still be rounded in shape because of self-gravitation. However, Mimas is not actually in hydrostatic equilibrium for its current rotation. What the fuck? Mimas was discovered by the astronomer William Herschel on the 17th of September 1789. He recorded his discovery as follows. I continued my observations constantly, whenever the weather would permit, and the great light of the 40-feet speculum was now of so much use, that I also, on the 17th of September, detected the seventh satellite, when it was at its greatest preceding elongation. The 40-foot telescope was a metal mirror reflecting telescope built by Herschel, with a 48-inch aperture. The 40 feet refers to the length of the focus, not the aperture diameter is more common with modern telescopes. Mimas is named after one of the giants in Greek mythology, Mimas. The names of all 7 then-known satellites of Saturn, including Mimas, were suggested by William Herschel's son John in his 1847 publication Results of Astronomical Observations Made at the Cape of Good Hope. Saturn, the Roman equivalent of Cronus in Greek mythology, was the leader of the Titans, the generation before the gods, and ruler of the world for some time. The giants were the subsequent generation, and each group fought a great struggle against the gods. The customary English pronunciation of the name is Mams, though some people attempt a more authentic pronunciation, Mims. The Greek and Latin root of the name is Mimant, and so the English adjectival form is Mimantine or Mimantian, either spelling pronounced Mamantin tilde Mmantin. The surface area of Mimas is slightly less than the land area of Spain. The low density of Mimas, 1.15 grams per cc, indicates that it is composed mostly of water ice with only a small amount of rock. Due to the tidal forces acting on it, Mimas is noticeably prolate, its longest axis is about 10% longer than the shortest. The ellipsoidal shape of Mimas is especially noticeable in some recent images from the Cassini probe. Mimas's most distinctive feature is a giant impact crater 81 miles across, named Herschel after the discoverer of Mimas. Herschel's diameter is almost 33% of Mimas's own diameter. Its walls are approximately 3 miles high, parts of its floor measure 6 miles deep, and its central peak rises 4 miles above the crater floor. If there were a crater of an equivalent scale on Earth, in relative size, it would be over 2,500 miles in diameter, wider than Australia. The impact that made this crater must have nearly shattered Mimas. The surface antipodal to opposite through the globe Herschel is highly disrupted, indicating that the shock waves created by the Herschel impact propagated through the whole moon. The Mimantine surface is saturated with smaller impact craters, but no others are anywhere near the size of Herschel. Although Mimas is heavily cratered, the cratering is not uniform. Most of the surface is covered with craters larger than 25 miles in diameter, but in the South Polar region, there are generally no craters larger than 12 miles in diameter. 3 types of geological features are officially recognized on Mimas: craters, chasmata chasms, and catenate crater chains. A number of features in Saturn's rings are related to resonances with Mimas. Mimas is responsible for clearing the material from the Cassini division, the gap between Saturn's 2 widest rings, the A ring and B ring. Particles in the Huygens gap at the inner edge of the Cassini division are in a 2-1 orbital resonance with Mimas. They orbit twice for each orbit of Mimas. The repeated pulls by Mimas on the Cassini division particles, always in the same direction in space, force them into new orbits outside the gap. The boundary between the C and B rings is in a 3-1 resonance with Mimas. Recently, the G ring was found to be in a 7-6 co-rotation eccentricity resonance with Mimas. The ring's inner edge is about 9,300 miles inside Mimas's orbit. Mimas is also in a 2-1 mean motion resonance with the larger moon Tethys, and in a 2-3 resonance with the outer F ring shepherd moonlet Pandora. A moon co-orbital with Mimas was reported by Stephen P. Sinnott and Richard J. Terrell in 1982, but was never confirmed. Fucking stupid shit. In 2014, researchers noted that the librational motion of Mimas has a component that cannot be explained by its orbit alone, and concluded that it was due to either an interior that is not in hydrostatic equilibrium, an elongated core, or an internal ocean. However, in 2017 it was concluded that the presence of an ocean in Mimas' interior would have led to surface tidal stresses comparable to or greater than those on tectonically active Europa. Thus, the lack of evidence for surface cracking or other tectonic activity on Mimas argues against the presence of such an ocean, as the formation of a core would have also produced an ocean and thus the non-existent tidal stresses. That possibility is also unlikely. The presence of an asymmetric mass anomaly associated with the crater Herschel was considered to be a more likely explanation for the libration. In 2022, scientists at the Southwest Research Institute identified a tidal heating model for Mimas that produced an internal ocean without any surface cracking or visible tidal stresses. The presence of an internal ocean concealed by a stable icy shell between 15 to 19 miles in thickness was found to match the visual and librational characteristics of Mimas as observed by Cassini. Continued measurements of Mimas' surface heat flux will be needed in order to confirm this hypothesis. Pioneer 11 flew by Saturn in 1979, and its closest approach to Mimas was 64,786 miles on September 1, 1979. Voyager 1 flew by in 1980, and Voyager 2 in 1981. Mimas was imaged several times by the Cassini orbiter, which entered into orbit around Saturn in 2004. A close flyby occurred on February 13, 2010, when Cassini passed by Mimas at 5,900 miles. When seen from certain angles, Mimas resembles the Death Star, a fictional space station and superweapon known from the 1977 film Star Wars. Herschel resembles the concave disk of the Death Star's superlaser. This is coincidental, as the film was made nearly 3 years before Mimas was resolved well enough to see the crater. In 2010, NASA revealed a temperature map of Mimas, using images obtained by Cassini. The warmest regions, which are along one edge of Mimas, create a shape similar to the video game character Pac-Man, with Herschel crater assuming the role of an edible dot, or power pellet, known from Pac-Man gameplay.